ABCD is a parallelogram. Prove that A, angle E1 is equal to angle F1. B, triangle AED is congruent to triangle CFB. And C, that DEBF is a parallelogram. Let's start with part A. Prove that angle E1 is equal to angle F1. Angle E1 has been marked on our diagram in black, so let's mark angle F1 as well. Now, the question tells us that ABCD is a parallelogram, and we can see that angle E and angle F sit on the diagonal AEFC. So let's make a note that AEFC is a straight line because it is a diagonal and parallelogram ABCD. E and F both sit on a straight line, which means that the whole of angle E and the whole of angle F must be equal to 180 degrees. This means that angle E1 plus angle E2 will be equal to 180 degrees. And it means that angle F1 plus angle F2 is also equal to 180 degrees. We have said in previous videos that if two equations are equal to the same value, then the equations themselves are equal as well. We know that angle E1 plus angle E2 is equal to 180 degrees. And we know that angle F1 plus angle F2 is also equal to 180 degrees. Both equations are equal to 180 degrees, which means that angle E1 plus angle E2 must be equal to angle F1 plus angle F2. Now, in order to prove that angle E1 is equal to angle F1, we need to prove that angle E2 over here is equal to angle F2. So we can cancel these values out of our equation. So what else do we have to work with? In the diagram, we can see that DE is parallel to FB. So let's make these two lines blue. EF touches both parallel lines. So let's make this our transversal line. Let's make it green. Now we have a Z shape, and we can see that angle E2 and angle F2 sit inside the Z shape. So let's make these angles blue. These are alternative angles, which we know are equal. So we can now say that angle E2 is equal to angle F2 because these are alternative angles. And we know this because DE is parallel to FB, and this information has been given to us. Angle E2 is equal to angle F2, and we know that in an equation, if we have equal terms on both sides of the equal sign, they will cancel each other out. So now we can cancel out E2 on this side and F2 on this side. Now we're left with angle E1 on the left, which is now equal to angle F1 on the right. And we have now proven these angles equal. Prove that triangle AED is congruent to triangle CFB. To get a better idea of what we're working with on our diagram, let's mark triangle AED in purple and triangle CFB in green. To prove that two triangles are congruent, we need to consider corresponding angles and corresponding sides. We don't know much about angle A and angle C, but in part A, we've just found that angle E1 is equal to angle F1. We've already proven this, so as our reason, we use proven above. We don't have enough information about angle D and angle B. So let's look at corresponding sides. We know from the question that ABCD is a parallelogram. And we know that in a parallelogram, both pairs of opposite sides are equal. This means that AD is the same length as CB. So let's put a small blue line on AD and a small blue line on CB. We also know that AB is the same length as DC. So let's put two small blue lines on AB and two small blue lines on DC to show that they are equal as well. AD is one side of triangle AED, and CB is the corresponding side in triangle CFB. So now we can say that AD is equal to CB because these are the opposite sides of parallelogram ABCD, and we know that these sides are equal. To prove that two triangles are congruent, we need three corresponding pairs. We have one pair of sides and one pair of angles, so we need one more. We don't know anything else about the sides of each triangle, so let's look at an angle. We know that parallel lines show us angle relationships. From the diagram, we can see that DE is parallel to FB, but none of the angles of the triangles sit between these two lines. So what else do we have to work with? We know that ABCD is a parallelogram, which has two pairs of opposite sides that are equal. But we also know that a parallelogram has two pairs of opposite sides that are parallel. This means that AD is parallel to BC. So let's put a small blue arrow on AD and an arrow on BC. We also know that AB is parallel to DC. So let's put two small blue arrows on AB and two on DC to show that they are parallel as well. AD sits in triangle AED and BC sits in triangle CFB. And we can see that the diagonal AC touches both parallel lines. So let's make this transversal line red. Now we have a Z shape, and we can see that angle A1, let's make it yellow, and angle C1, let's make it yellow as well. Both sit inside the Z shape. So these are alternative angles which are equal. So we can now say that angle A1 is equal to angle C1 because these are alternative angles. And we know this because AB is parallel to BC because these are the opposite sides of parallelogram ABCD, which are parallel. Now we have two pairs of corresponding angles and one pair of corresponding sides. So we have now proven that triangle AED is congruent to triangle CFB because of two angles and a side. So as our reason, we use AAS for angle, angle, side. Prove that DEBF is a parallelogram. Let's mark DEBF in red. There are 5 ways to prove a parallelogram. We can prove that both pairs of opposite sides are equal, or both pairs of opposite sides are parallel, or we can prove that both pairs of opposite angles are equal, or that the diagonals bisect, or we can prove that one pair of opposite sides are equal and parallel. DEBF only has one diagonal, so we can't use this reason. We also don't have enough information about the interior angles. So to prove a parallelogram, we need to consider the sides. The diagram shows us that DE is parallel to FB. So we can make a note that DE is parallel to FB. And we know this because this has been given to us in the question. Now we either need to prove that DF is parallel to EB, or we need to prove that DE is also equal to FB. Remember that we can use our answers from one part of a question to help us solve the next part. In part B, we found that triangle AED is congruent to triangle CFB. And we know that if two triangles are congruent, then corresponding sides are equal. So let's mark the corresponding sides on our diagram. We know that AE is the same length as CF. So we can put a small green line on these two sides. And we know that DE is the same length as FB. So we can put two small green lines on these two sides to show that they are equal as well. DE and FB are also opposite sides of DEBF. So we can use this to prove that DEBF is a parallelogram. We know that DE is equal to FB because triangle AED is congruent to triangle CFB, and we have proven this above. Now we can see that DE is parallel to FB and the two sides are equal as well. This is enough to prove a parallelogram. So as our final answer, we say DEBF is a parallelogram because one pair of opposite sides is equal and parallel.